Good morning. I'm going to go through the answers. Number 1 is C. Number 2 is G. 3 is A. 4, F. We've done that on a quiz before. Number 5, is B. Number 6, H. And 7 is B. In number 1, we're asked to find the minimum of the function. Minimum occurs, either minimum or maximum, at the vertex. The coordinates of this vertex are 2, -8. And the minimum value is always going to be our y coordinate of our vertex. So that would be this -8, which matches answer choice C. For number 2, we're asked to find the equation of the line that's parallel to the graph y equals -2x plus 5. So parallel lines have the same slope. Looking at the equation of the line that we're given, the slope of that line is -2. So our parallel line would also have a slope of -2. Looking at the answer choices, we have a slope of 1/2, slope of -2, -1/2, and 2. The only answer that has a slope of -2 is G. In number 3, we're asked to find, the table that shows the slowest rate in kilometers per second. And we're told that X is the number of seconds and Y is the kilometers. So rate, so we're thinking about rate of change or we're thinking about slope. So our formula for slope, either you're thinking about it as the change in Y over the change in X, or the slope formula that's given in our STAR reference sheet, where we're taking the difference of the Y coordinates over the difference of the X coordinates, same thing. So for each of these tables, I'm going to calculate the change in Y and the change in X. And if you do that for each one, for A, we have 78 over 10. This is your change in Y over your change in X, which would be 7.8. And if you do that for each table, this is 32.4, so 32.4 over, 4 is 8.1. This one here will be 7.9, and then 8 for D. So the lowest rate of change, or our slowest rate, would be A, because we're going the fewest. This is kilometers per second. Okay, number 4, we've done this one before on a quiz, but we have, so we need to think about this 15/6. I've seen people write, let me just write it all out. I've seen people kind of separate these, which is a great idea. But we need to see 15/6 as 15 divided by 6. I'm going to just simplify this because I see that the answer choices are kept as fractions. So 15/6 share a common factor of 3. If I divide both the numerator and denominator by 3, I would have 5 halves. Okay, and then I'll have, so the rule of quotients of exponents says that when the base is the same, so I have W and W, I subtract those exponents. So it'll be -3 minus a -2, x 5 minus a -2, and then y, there's an invisible 1 on this y in the denominator, it would be 2 minus 1. So that I'm left with 5 halves, w, -3 minus -2 is w to the 5th, x to the 7th, and then y to the 1st. oh, I did that wrong. This is not. -3 plus a +2 is a -1. There we go. So everything stays on the top except for this w, because our negative exponent says that I can rewrite as a positive exponent 1 over the base to the positive exponent. So I would have w to the first power, and then everything else remains in the numerator. And that's answer choice F. When I look at number 5, I'll switch a different color. When I look at number 5, we're asked to find the quarters and dimes. Total number of quarters and dimes is 180, and then the sum of the value of those coins is $22.50. So if I define X as the number of quarters and Y as the number of dimes, I know that the total number of coins that I have is 180, and then their worth, so each quarter is worth 25 cents, and each dime is worth 10 cents. That total worth is $22.50. Okay, and I probably should have put this someplace else because I don't have a lot of room here. But let's take this up here. All right, and then there's several ways you can do this. You can use substitution. I'm going to use elimination, and I'm going to try to get rid of this y. The way it's written right now, I can't do that, but if I could work some magic so that y was in this top equation was negative 1/10 y, then I could eliminate it. So I'm going to go ahead and multiply both sides by negative 1/10 y. And that'll leave me negative 1/10 x minus 1/10 y, and then negative 18. And if I add those together, these cross out, I'm left with 1500th x, and then is equal to $4.50. If I divide both sides by 1500ths, then I would get x is equal to 30. If x is equal to 30, that means y is equal to 180 minus 30, which is 150. And then let's just check to see if this is correct. If I I want to make sure that this, my 30 quarters and my 150 dimes really do add up to $22.50. So I can multiply 25 cents times the 30 quarters plus the 10 cents times the 150 quarters. Does that equal $22.50? This would be $7.50. This would be $15. And if I'd add them together, it would be $22.50. Okay, in this problem we're asked to find which statement is not true. Okay, so it says here the initial population was 4,000 fish. Well, I might think, oh, well, this is wrong because my y-intercept is 4. But if you look at the label on the y-axis, it says that these numbers are in thousands. So this 4 would actually be 4,000. So that is actually true. So it can't be F. G, the initial population will be decreased to less than half by year 4. Well, we're not quite sure yet. So I'll investigate that one more. Let's keep going. H says the population is decreasing 800 each year. Well, this should kind of give me a flag because this is an exponential function, it says this. And that means that our rate of change is not going to be the same. It's not going to be the same 800 every year, but let's just verify. So if I go from 4,000 to 3,200, remember these are in thousands, then 4 minus 3.2 is equal to 0.8, which in this case is 800. Okay, so that matches. But then if I go to the next point, I have 3.2 minus 2.56, which is, sorry, this should be negative 8 because we're decreasing. So we're going down by 800. This is negative 64 hundredths, which would be 640. Negative 640, which is not a constant rate of 800. So this is not true. And we could really stop here. But we can see that the population is decreasing by 20% each year. So 4,000 times 20% is 800. And then if I did 3,200 by 20%, that should be 640. Let me just verify. Yeah, so we're good. And I don't really need to check G, but you could see if you went ahead and calculated, subtracted 20% from this Y value here, it should be below 2, which is basically what we want. It's less than half. So this one had a lot of words, and I was kind of gearing up for something that was really complex. But then I realized that really all they're looking for is the domain, which are our x values, of these 4 points in our solution set. So all I have to do is look at the x values of these points. So that would match answer choice B.